Here, first we can take one right angle triangle with hypotenuse 1 unit. Then draw another right angle triangle. Then use the same hypotenuse. That means that right angle triangle hypotenuse also 1 unit, the same 1 unit. We can draw it like this. Then the next part, here two angles formed. We can mark this angle, one x, other y. The next we can draw one line from here to down. The same way we can extend this line like this. Then here one more right angle form. It will come like this. The next we can draw from this point. We can draw one perpendicular to this line. It will come like this. Okay. Then next we know this angle x. Then we are going to find this angle. Then this angle also x. Why this angle also x? Because these two lines are parallel. If two lines parallel means we know alternate interior angles are equal. That means this angle x means what about this angle is also x. Then next we know this total angle 90 degree. We know one part that is x. Then we can find the another part 90 minus x because total is 90. Then here in this triangle we can apply angle sum property. We know sum of angles in triangle 180 degree. Then we know two angles, one angle 90, the other angle 90 minus x. Then we can find the third angle. Then take it y. That means we can write it. Now this angle x means what about this angle? That angle also x. Now consider that before that one we can mark the each vertex. Okay. Then this vertex is A. The next B, C, D, E. Then one more. Here this vertex also we can mark. That is F. Okay. Now consider the triangle ADE. ADE means is the triangle ADE. That means this triangle ADE. In this triangle we know this angle y. Then we can first apply sine y. Sine y means opposite side over hypotenuse. Hypotenuse means opposite to 90 degree. That is this one. We can write sine y is equal to ED over 1. That means ED is equal to sine y. That is instead of ED we can write sine y. The same way if you take cos, then cos y is equal to adjacent side. Here adjacent side AD. That means AD over 1. Then AD is equal to cos y. That is instead of this AD we can use cos y. Then consider the next right angle triangle EFD. That is this right angle triangle. Okay, the smallest one EFD. Then here we know this angle x. Then this case hypotenuse opposite to 90. That is this is the hypotenuse. And this if we apply sin x, opposite side is FD. Then this opposite side we can use, that is sin x is equal to FD over sin y. Then use here we can do cross multiplication. That is FD is equal to sin x times sin y. That is instead of FD we can write sin x sin y. Then next we can apply here cos, that is cos x, that is adjacent side, over hypotenuse, that is we can write FE over sin y, cos x. Then do cross multiplication. We will get FE is equal to cos x sin y. Then we can mark that one there. Okay. Then next the third right angle triangle, we can use that right angle triangle ACD. That is this right angle triangle. In this right angle triangle we know this angle x. Then here in this case this is the opposite side and this one is the adjacent side, and the side opposite to 90, that is the hypotenuse, here cos y. Then here sin x is equal to DC over cos y. Then do cross multiplication, we will get DC is equal to sin x cos y. Then the place of DC we can write sin x cos y. Then next we can apply the same right angle triangle cos, that is cos x is equal to AC over cos y. Then do cross multiplication, that is AC is equal to cos x cos y. That means instead of this AC part we can write cos x cos y. Okay. Then next consider the big right angle triangle, that is this one. We know this angle, this total angle we know, that is x plus y, that is this total angle. The next we are going to apply here sine and cos. Then here this angle we know x plus y. Then this case the opposite side, that is EB, and the adjacent side, that is AB. The hypotenuse opposite to 90 degree, that is hypotenuse, here it is 1. Okay, then first we can write sine x plus y. Sine x plus y is equal to BE over 1, that is sine x plus y is equal to BE. We can split BE by using this F, that is BF plus FE. Then we know BF. BF is same as which one? CD. Okay. Then BF, that BF place we can write CD. Then sin x plus y is equal to CD plus FE. Then we know the value of CD, that is sin x cos y, and the value of FE, that is cos x sin y. And substitute that value, we will get the first identity, sin x plus y is equal to sin x cos y plus cos x sin y. That is the first identity. Okay, then we can find the second identity. Use the same right angle triangle. We know here we are going to take cos x plus y, that is adjacent side, that is AB over 1. Then that is cos x plus y is equal to AB. Then we can write this AB as like this, the total AC minus this part, that is BC. Then we will get AB, that is AB is equal to AC minus BC. We know BC same as which one? FD. Then instead of BC we can write it here FD. Then substitute the value of AC and FD. What is the value of AC here? That is cos x cos y, and the value of FD, that we know that one, that is sin x sin y, and substitute here. That means we will get the second identity, cos x plus y is equal to cos x cos y minus sin x sin y is the second one. Okay, thank you.